Good morning, children. Nice to see you from the school physics lab. Today we'll continue with the chapter. Turn to page 29. Determination of density of solids. Determination of density of solids. Okay. So, in that, first one, density of regular solids. Regular solids means the solids which have the length, breadth and all is measurable. Okay, so in this the length is measurable, the breadth is measurable. Okay, it's a cube basically of maybe 1.5 centimeter. Okay, that's one. Then this is a cylinder. Okay, and this is a sphere. Okay, this is a sphere. Now we are going to find the, for example, we are going to find the volume of the sphere. Volume of this sphere. Okay, so first we have to find the density of the sphere, for which I need two things, mass and volume. Okay, density is equal to mass upon volume. So I need both mass and volume. Okay, mass I'll be finding it using a beam balance, physical balance, that is the balance used by you would have seen Sabjiwalas and all using, that is physical balance. Okay, I'm going to use another type of balance that is helps me to find its weight. Okay, so there are some graduations. I don't know whether you're able to see it. Okay, so this graduations are showing 75 gram. Okay, the weight of this is, the mass of this body is 75 gram. Okay, mass is 75 gram. Then I have to find its area. Okay, so I'm finding its diameter first. This much is its diameter. You know the formula for volume of a sphere? Yeah, have you studied in maths? Okay, so I cannot measure it with a scale, so I did it with a thread, and then I am now, okay, it's 7.5. This is diameter. Okay, so with the thread I measured this diameter. Okay, I rolled it on this, and then okay, I marked that, and then I took this much and measured it, and it was, so that is the diameter. Okay, so diameter is 7.5 centimeter. Okay, so then volume of 7.5 centimeter. So volume of sphere, you know the formula for volume of sphere? 4 by 3 pi r cubed. Yeah, so if diameter is 7.5, then radius will be 7.5 by 2, that is 3.75 centimeter. Okay, so now I have to find the volume first by putting it in this formula, 4 by 3 pi, you know the value of pi. Okay, 4 by 3, pi's value is 3.14 into r cubed is 3.75 into 3.75 into 3.75. So I have to calculate the value of this, and that will give me the volume of this sphere. Okay, so once I know the volume, I know the mass, then I put it in this and get the density of this particular material. Okay, it's a solid bob, we call it a pendulum bob. So that will give us the density of the density of this one. Okay, so the point is, if it is a regular solid, then I can easily find its density. because volume I can, so if it is a cube, volume will be side cubed. Okay, so I know the formula, and knowing the formula I'll find the volume. Then mass I can find it using the physical balance. Then I put it in this and get the density. Okay, so that is the first part, density of regular solids. Okay, so if the given solid is of regular shape, cube, cuboid, cylinder or a sphere, then the volume of such regular shaped solids can be easily determined by knowing their dimensions and applying appropriate formula. The mass of the given solid can be measured using a beam balance or physical balance. Knowing mass and volume, we can easily determine the density of the solid by applying the formula density is equal to mass upon volume. Okay, now we are going to go to the next one, density of irregular solids. Density of irregular solids, which is heavier than water. So, in this case, so regular solids, it's very easy, okay, because you know the formula for the finding the volume of these bodies. Okay, if I have a body like this, a stone, it's of irregular shape, okay, or I have a bottle here, again it's broad at the base and it's going narrow here, and then cylindrical top, sorry, circular top, and so it's not a uniform shape, right? So in these cases, directly finding the volume using a formula is really difficult, okay, because it's of irregular shape. Okay, till there's one shape, then there is a different shape, then there is a different shape, and that too there's a flat part here, okay, and this part is broad than this. So this is an irregular shaped body. I can't apply a single formula to get its volume. Okay, in such cases, how do we find the volume of this body to get the density? Okay, so that is what we are going to see. So density of irregular solids. Okay, irregular solids. Okay, I'm going to show you an experiment how to find the density of this this bottle. Okay, it's a glass bottle with some stones inside. So how to find the density of this bottle? Okay, for this I need the help of a measuring cylinder. Okay, so this is a measuring cylinder. Okay, there are graduations. I don't know whether you're able to see. Okay, so there are graduations. I have taken water till 950 gram force, 950 centimeter cubed. Okay, okay, so it's 850 centimeter cubed. Okay, so the initial volume, I have taken water in the cylinder till 850 centimeter cubed. Okay, so I note that down. Initial reading is 850 centimeter cubed. Now what happens if I put this inside, okay, this is the body, the irregular shaped body whose density has to be found. So to find its volume, what I should do is I should put it inside a jar containing jar containing water up to a known level. Okay, you know the level, you know that there is, before I put this inside, there's water till 850 centimeter cubed. Now when I put this inside, what will happen? The level is going to rise. Okay, the level is going to rise. Okay, and then I have to note down the final reading. Okay, by keeping it inside, the level will rise and I have to note the final reading. Okay, so it's nearly 1000. Okay, it's 1000 centimeter cubed. Okay, so when it was inside, it was sorry, when it was not inserted, it was 850. When I inserted it, it is showing 1000 centimeter cube. So the final level, the final reading of this is 1000 centimeter cubed. I have to subtract these two. Okay, if I subtract these two, that will give me the volume of water displaced. You understand the meaning of displaced? Okay, how much has been the rise in the level of liquid? That's called volume of water displaced. So 1000 minus 850, that is 150 centimeter cube, and this is the volume of the solid. So the concept that we are using is, when I immerse this inside liquid, the amount of liquid displaced by it, here it's water, so the amount of liquid displaced by it will be the volume. How much is the volume of this one? That much water only it will, because when I put it inside, it takes this place of some of the water, and so the water level rises up. So if I know by how much level the water has risen up, the volume of the risen up water, the raised water, that will give me the volume of the solid. Hope you understood this. So if it is an irregular solid, we cannot use a scale or a formula to directly measure it. So in those cases, we have to take the help of a measuring cylinder and take water to a known height, because it has readings. So I know what was my initial volume of water, then after putting it, what was the final level, then I have to subtract these two, that gives me the volume of water displaced, and that is the volume of the solid. That is the volume of this solid. Can you understand? So it's an indirect way of finding the volume. Okay, as usual, then I can find the mass of this body using physical balance. So this is actually called spring balance, children. It's used to find something called weight, but I'm using it to find mass. Okay, so it's 180. Okay, 180 gram. So its mass is 180 gram. So density will be mass upon volume, which is equal to 180 gram upon 150 centimeter cubed. Okay, so 6 upon 5, that will be 1.2 gram per centimeter cubed. So the density of this body, okay, it's a glass bottle, is 1.2 gram per centimeter cubed. Hope you have understood, children. So if it is an irregular shaped body, then I have to use this method to find the density of the body. Okay, so we have some numericals also based on that. Based on this, we'll be doing that. So this is another way of finding the volume of irregular bodies. This is called a Eureka can. Okay, Eureka can. Okay, so if you see, this has a spout. Spout means from where water can drop. Okay, so initially I will take water till this one. Now the water is not falling. Okay, so I've taken water till the tip. Okay, now when I submerge this, so suppose this is the irregular body whose volume has to be found. I submerge it inside the body, so it will displace some. Okay, so some water poured out through this, so I have to collect it and then measure its volume. Okay, note down. So I use a measuring cylinder itself, so it will directly measure its volume. That is also one another way. Okay, so this is called Eureka can. It has a spout. So I'll take initially water till this, and when I put the body, the water will rise and the extra water will come out through this. I collect it in a small measuring cylinder, and from that directly I can measure the volume of it. That's another way of finding. Okay, it's given in your book, so that's why I explained. Okay, look at your book now. Let there be a solid of irregular shape which is insoluble in water and denser than water. Determine its mass by using beam balance. Determine the volume by displacement method using either a measuring cylinder. So this was the measuring cylinder one, and this is the Eureka can one. Okay, also known as an overflow can. Knowing mass and volume, we can calculate density of the given solid using this formula. Density is mass upon volume. Okay, so they have shown this activity in the diagram. Okay, this is the initial level, and then the level rises after the solid is put inside. That's the final level. If I subtract this, I get the volume of this irregular body. They also have explained how we can do with an Eureka can. In that case, you have to keep a measuring cylinder. It is empty. This measuring cylinder will be empty first. Water will be there till this in the Eureka can, and then when I put the solid, the extra water that rises up will fall through this and it gets collected here, and then I can just note down the reading from here. That gives me the volume of the irregular solid. Okay, so this is another way of finding the volume of these irregular solids. Okay, so now we are going to do some numericals based on this this method, okay, to find the density of irregular solids. Yeah, turn to page number 31. We are going to do these two example numericals. Okay, they are very simple. Now that you have seen the experiment, it will be very easy for you to find the solve this numerical. Okay, a stone piece weighs 125 gram. Weighs means weight, or mass is 125 gram. When the stone piece is immersed into water contained in a Eureka can, 55 centimeter cubed of water is displaced from the can and collected in a measuring cylinder. So what is this? This is the volume of solid. This is the volume of the stone piece. How much ever water was collected in the cylinder, that will give me the volume of that stone piece. In this case, I don't have to subtract or anything. I just have to take this to be the volume of the solid. Now, then we have to find the density. Okay, so density is mass upon volume. Mass is 125 gram. Volume is 55. So I cut it in two. 25 and this is 11. So it will be 2.26 something gram per centimeter cube, or 2.27. okay, they would have taken one more digit and then they would have rounded it off. So 2.27 gram per centimeter cubed is the density of that particular stone. Okay, so this is classwork. Okay, then see the example number 7. A measuring cylinder contains water up to the level of 46 ml. ml is the same as centimeter cube. 1 ml is equal to 1 centimeter cubed. Okay, so if I say 46 ml, it means 46 centimeter cube. The water level rises to 74 ml when a rubber stopper is immersed into it. Okay, this is the finding the volume using the measuring cylinder. So initial level of water, or just write initial level, was 46 centimeter cubed. Final level, the water rises to, that is the final level. So final level will be 74 centimeter cubed. So volume of this, it's a stopper. Okay, volume of the stopper will be 74 minus 46. You have to subtract. In this case, directly you can take this as the volume, but in this case, volume, to find volume, you have to subtract this. Okay, so it will be 28 centimeter cubed. So volume of this, that particular body, was 28 centimeter cubed. Okay, then what else is given? Its mass is given as 45 gram. The mass of the body is given as 45 gram. So I can find density using the formula mass upon volume 45 divided by 28. Okay, so it should come out to be 1.61 gram per centimeter cubed. Is it clear, children? So this is the these are the numericals based on the experiments that I did today. Is it clear? So I'll quickly tell you the homework. 6, 7 and 8. Homework for today are page 41, numerical 6, 7 and 8. Also, you have to write the answers for these 3 questions. Okay, answer these questions 1, 2, 3. Define density and give its SI unit. Does density depend on its shape or size and all that? Give an activity to find the density of an irregular solid which is heavier than water and it's insoluble in it. You can choose any one. Okay, there are 2 methods, either using a measuring cylinder or using a eureka can. Okay, this will be the simpler and easier one. You can write this activity with the diagram. You have to draw this diagram also, and there is the little calculation here. The whole thing you have to write for this. Okay, I hope you have understood this concept clearly. Okay, children, thank you so much.